Here we have the Calculus Chapter 1 exam review number 4. This one's just taken from the 2010 Form B of the APA Calculus AB exam number 4. Very close, not exactly. Anyway, this problem is talking about a squirrel that starts at building A at time is 0 and travels along a straight wire connected to building B. So, building A, building B. Okay, there's just a wire there, the squirrel's going along the wire for 18 minutes, okay, or whatever time interval we have. The squirrel's velocity is modeled by this function over here. So again, this is the velocity versus time graph, okay? And our first question is, at what time or times in the interval between 0 and 18, if any, does the squirrel change direction? Well, we know when the velocity is positive, right, it's going in one direction, and when it's negative, it changes. So at this point, it goes from going one way along the wire, right, and then it turns around. So at that point, the little squirrel turns around right there. Okay, so we know t right there is 9, and then it turns around once more at t is 15. So part A, what time? At t equals 9 minutes, and at t is equal to 15 minutes, okay? Because this one goes from positive to negative velocity, so we know there's a change, and this one goes from negative to positive velocity. Okay, part B then says, at what time in the interval from 0 to 18 is the squirrel farthest from the building? Okay, so building A, how far is it from building A? Well, we know that it's going away from building A this whole time, right? That's from 0 to 9 seconds, it's going away. Then it turns around and goes back to building A for the next few seconds until the time is 15, and then goes on forward until 18. Okay, so this we know it's going away from building A. This one's going toward building A, and this is away again. And remember, the distance is just found from a velocity versus time as the area underneath the curve. And I can quickly see that the area inside this section here is smaller than the area inside this section here. So when it turns around, right, it goes to building B, it turns around, it never gets back to this point where it turned around. So at time is 9 is the furthest I am away from building A. So at time is equal to 9 minutes, I am furthest or farthest from building A. Okay, and what is that distance? Well, I know the distance is just the area beneath the curve, right? And so I could go ahead and look at this area right there. And I know that I could break it up into a trapezoid, or I could just have a triangle here in blue, and another triangle here in blue, and the rectangle in the middle. And the area of a triangle is 1/2 base times height. And the base is 2 and the height is 20. The base for this one's 2 and the height is 20. And the base for my rectangle is from 2 to 7 is 5 and a height of 20. So the area is 1/2 base times height, so it's 2 times 20 plus 5 times 20 is the rectangle, plus 1/2, 2 times 20, right? And so that just gives me 1/2 times 2, well that's 1 times, so that's 20, plus 5 times 20 is 100, plus 20 again, so that's 140 units, and I am told that for my units, meters per minute and minutes. So meters per minute times minutes is meters. So I'm 140 meters away from building A. And that's, again, at time is equal to 19. Let me box all these answers. And I'm on part C. Part C asks, find the total distance, not displacement, that the squirrel travels. So remember distance, then we've got to go ahead and add up all of the traveling that the squirrel does as positive. So when he's backtracking, he's also traveling, so that's distance that he's covering. So it's like how much time is he actually moving. So remember, distance is going to treat this as positive. We just calculated that this section here, I'm going to write it, is 140, right? This section here. This one here, I'm going to do really fast. It's just this rectangle in the middle is 10 by 1, 2, 3, 4, so that's 40. And this triangle here is 1 by 10, so it's 1/2 times 1 times 10, so that's 5 and 5. So this whole thing is 50, right? So that's 50 meters that he's traveling back toward building A. And this triangle here is 1/2 times base of 1 times height of 10. So that's another 5. And here we have a rectangle with a base of 2 and a height of 10, so that's 20. So this one is 25 meters that he travels back away from building A. So his total distance is 140 plus 50 plus 25. So distance is equal to the area. All area is positive. So that's equal to, again, 140 plus 50 plus 25. And that gives us 215 units. But again, we're meters that the squirrel travels in that 18-minute time span. Okay, part D asks to find the average rate of change of v, so the average velocity, so v average. And in the hint it says, what does the hint say exactly? The average velocity is the change in displacement divided by the change in time. And we're looking at the change in time between 7 and 16. So let's go ahead and write that change in displacement. Okay, over change in time. Okay, so let's go ahead and see, well, how far does he move from the time is 7 to the time is 16? So here's 7, right? And here's 16. And for displacement though, we have to count this as negative 50, right? So we know this triangle right here from 7 to 9 seconds is 1/2 base times height, which is 1/2 times 2 times 20, which is just 20 meters, right? And 16, we know this triangle right here is 5. So he travels a total of 20 meters to the right toward building B, 50 meters back, and 5 meters back to the right again. So he goes 20 to the right, 50 left, 5 right. So that's just going to be 20 to the right plus negative 50 to the left plus 5 back. That's the displacement now. And divided by the time, we know we're going from 7 to 16 minutes. So that's 16 minus 7 minutes. 20 minus 50 plus 5 is 25. Sorry, negative 25. And that's over 9, right? And so we can leave that as, and remember, we're meters per minute. So that's exact. Or if we approximate with our calculator, I get negative 2.778 meters per minute. Okay, so either one, and if we approximate, make sure we go to the third digit after the decimal. Okay, so that's the average velocity between 7 and 16 minutes. Okay, so that's going to end our review of number 4 on the Chapter 1 exam.